All right, let's jump right in. Today we're talking about maybe the coolest piece of tech in all of science fiction, the holodeck from Star Trek. But we're not just going to geek out about Star Trek. We're going to use this incredible idea as a way to understand the very nature of reality itself.
I mean, what if this device, which seems like pure magic, actually gives us a really powerful way to think about how time, matter, and information work in our own universe? That's the big question we're going to be exploring today, using the holodeck as our guide to unpack some seriously deep physics.
But okay, before we get carried away, let's get one thing crystal clear. This is a thought experiment. We are not saying that we can build one of these things. No way. The amount of information and raw computing power you'd need to recreate even a tiny sliver of the past is, well, it's just astronomical. It's completely beyond us, so we're using this as a model to help us think, not as a blueprint to actually build something.
So, with that in mind, let's reimagine what a holodeck really is. Forget about the entertainment for a second. Let's look at it as a kind of conceptual laboratory, a place where we can try to understand how time itself might pop into existence from even more basic rules. So, in our version, the holodeck isn't just projecting fancy illusions. It's a pure computational system. It takes raw information, just data, and rebuilds it into physical states that have to follow the laws of physics. And in this little pocket universe it creates, time isn't a fundamental force. It's a simulated effect. It emerges from the process.
Now, to even begin to get our heads around how that's possible, we have to start with one massive core idea. The idea that our entire physical world is built from something even more fundamental than particles. It's built from information.
This is something called information-matter equivalence, and it's a wild idea. Think of it like this. Every single particle, in you, in the chair you're sitting on, in the stars, it isn't just a tiny little ball of stuff. It's actually a packet of data, a little bundle of instructions. So here's the key. Matter is information, just in a form that we can see and touch. So let's say you wanted to use our holodeck to meet Isaac Newton. The system wouldn't be performing some kind of magic resurrection. Nope. It would first act like a cosmic search engine and find the exact information pattern that was Isaac Newton at a specific moment in time. Then, it would copy that data, and finally, it would paste it, reassembling it into a new, virtual state. You wouldn't be talking to a ghost, you'd be talking to a perfect informational replica.
Okay, so if matter is just information, what makes that information do anything? What pushes the play button and creates our experience of time passing? Well, that brings us to the second core principle, and it's all about a concept you've probably heard of before: entropy.
You know, we all feel time moving in one direction, right? It's the arrow of time. But in this model, that arrow isn't some cosmic river we're all floating down. It's just a side effect. Time seems to move forward for one really simple reason. The amount of disorder, or entropy, in the universe is always increasing. That unstoppable, constant increase in messiness, that's what we perceive as the passage of time.
And this is where the comparison really clicks. In our universe, the growth of entropy is universal. It's irreversible. It's the master clock for absolutely everything, and you can't turn it off. But inside our theoretical holodeck, entropy can be controlled. It's programmable. You could start it, stop it, or even reset it to a more orderly, low-entropy state, which would be just like rewinding the clock inside that simulation.
And what's really neat is that this idea just completely sidesteps all those tricky time travel paradoxes. See, you can't go back and change the past because the past isn't a destination you can travel to. It's just a configuration of data, like a saved game file. When the holodeck reruns that file, it isn't changing history. It's just starting a new, separate simulation that happens to be based on that old data.
So now we've got the two main pieces. Matter is information, and entropy is the clock that makes it all move. Let's zoom out and see how this whole holodeck analogy could actually be a small-scale version of how the entire universe works.
So it all comes down to these three core principles working together. Matter is the data of the universe. Entropy is the clock that dictates how that data evolves and changes, and that brings us to the final, crucial piece of the puzzle that governs the whole system: gravity.
So what's gravity's job in all of this? Well, you can think of it as the universe's bandwidth. You know, just like your internet speed limits how fast you can stream data, gravity puts a limit on how fast information can move and interact across space-time. It's the cosmic regulator, the thing that keeps the engine of reality from running out of control.
As we start to wrap this up, it's really important to come back to where we started.
The holodeck is just a powerful metaphor. It's a mental model that helps us grasp these really abstract, complex ideas. It's a tool for thinking, not a prediction of future technology.
But maybe the most profound idea here is captured in this quote. It suggests that this whole cosmic process isn't just happening out there among the galaxies. It's also happening right here, inside our own minds. Every single time you remember something or imagine the future, you're essentially reassembling information patterns. You're running your own little personal holodeck, a tiny simulation where entropy and your own mind write the script of time. And that leaves us with a pretty big final thought to chew on. Is time this external thing, this river that just carries us along for the ride? Or could it be something much more intricate, an unfolding story that the universe is constantly telling itself as its information rearranges, moment by moment? Something to think about. Thanks for watching.